So now that we've looked at how we can interpret a chemical reaction in terms of particles and in terms of moles, let's take a look at how we can interpret in terms of grams, and then we'll talk a little bit about liters. So let's switch over to the next page. And so we say we've got 2 hydrogen, back to our original reaction, reacts with 1 oxygen to produce 2 units of water. And we interpret these in terms of moles. And so let's use this reaction here, or this interpretation. 2 moles of water, and we will continue from there. And let's interpret this in terms of grams. Well, we know that we can convert 2 moles of hydrogen gas using the periodic table and atomic masses. I know that 1 mole of hydrogen gas is the equivalent of 2.02 grams of hydrogen gas. Remember, there's 2 hydrogen. So if I have 1 mole is equivalent to 2.02 grams, 2 moles would equal 4.04 grams of hydrogen gas. And we'll do the same for oxygen. 1 mole of oxygen gas. Now remember, we're dealing with O2, so instead of 16.00 grams per mole, this would weigh 32.00 grams for every 1 mole of oxygen. And that's going to equal 32.00 grams worth of oxygen. That's my reactant side. Taking a look at the product side, and let's just change colors here for illustration purposes. 2 moles of water then. Well, what's 1 mole of water weigh? Let's do the molar mass of water. Up here, if I have 1 hydrogen, it's going to weigh 1.01 grams, but I have 2 of them, and so that's going to get me 2.02. We're talking about the oxygen. Each oxygen is 16 grams per mole, and I only have 1 of them for every water molecule. That's 16.00. So the molar mass or atomic mass of water, the molar mass of water is 18.02 grams per mole. And so 2 moles of water we said that 1 mole of water weighs 18.02 grams worth of water. So that's going to equal a total of 36.04 grams of water. Something interesting that pops out about this, if you think about this in terms of the law of conservation of matter, if I separate my reactant side from my product side, if I add up all of the reactants, so I have 4.04 grams worth of hydrogen on the reactant side, 32 grams worth of oxygen on the reactant side. That comes out to 36.04 grams worth of reactants. Notice that that matches the 36.04 grams of products that I have. This has to come out. Anytime I have a balanced chemical reaction, this illustrates the law of conservation of matter. And it has to be the case because matter can neither be created nor destroyed, so I better end up with as much mass on the reactant side as I have on the product side. It also shows a perfect stoichiometric ratio. If all of these react in this amount of mass, then I get a perfect stoichiometric ratio. If I were to react 4.04 grams of hydrogen with 32 grams of oxygen, or some ratio of those masses, then I would have a perfect stoichiometric ratio. I would have no reactants left over, and I would produce 36.04 grams of water. Okay, so now we can interpret this in terms of particles, moles, grams, and for right now, let's just discuss the fourth method would be liters of gas. And let's assume that all of these are gaseous particles. And we know that 1 mole of a gas, you don't know why yet, and we'll do some work to help you with this, and we get to something discussing gas laws. 1 mole of a gas takes up 22.4 liters of space, and we say this is at conditions known as STP. Let me make that a capital T. STP stands for standard temperature and pressure. With that, if I were to interpret this reaction in terms of 2 moles, 1 mole, 2 moles, just want to put my coefficient 1 in here. 2 moles, 1 mole, 2 moles. And I were to multiply 2 and 1 and 2 by 22.4 for each liter, I would get the same numbers for each of them, the same ratio. And so when I'm interpreting this in terms of liters, not only does this stand for particles and moles, but I can also say that if it's all gas, 2 liters of hydrogen gas will react with 1 liter of oxygen gas to produce 2 liters of gaseous, and remember these are all have to be, you can't do this with liquids and solids. That's a common mistake kids try to make. It's put this into liters of solids and liquids, and you can't do that. Okay? Let's summarize this part